So hello, I am now going to be recording to show the final demonstration of our project for CS204. So this will be our final project, which is called the Minecraft calculator, and we only have addition. Now I'm going to be explaining our components that we use to able to make this possible. So first things first, I'd like to explain where we start from, and I slowly move up to how we built the display, how we made it work, stuff like that. So the first thing we ever did was a binary adder. Well, first we start off with an adder, and then we started with a binary adder to connect the adder to add in more digits. So right now this is a 4-bit binary adder, and so this is a 8-bit binary adder, and it's a more compacted version as well because instead of taking up space like this, we've made it more compact, so it's more squished in together. It's like a whole cluster, and it doesn't take as much space as this one. This one is only 4-bit, and it's already taking so much space, so it doesn't, yeah. So now let's just show you how the binary adder works. It'll be really quick. So this will be input A, this will be input B. So this represents 1, this represents 1, this represents 2, this is 4, this is 8. It's like binary number, basically. It represents a power of 2. So this 2 to the power of 0, to the power of 1, to the power of 3, of 2. So yeah. So now let's click 1. This is 1. So this is, again, this is input A, this is input B. So 1 plus, let's say 4, should be equals 5. So this is 4, this is 1, that is 5. That's indeed correct. Let's try one more time. Let's try 4 plus 8 should be 12. So yep, this is 8, this is 4, it's 12. So the addition of this binary adder works. So after we did that, we started to work on an encoder. So basically what an encoder is, I'll give the world some time to load. So basically what an encoder is, it basically encodes. So let's say right now we made a keypad for the numbers, just 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. So we made the encoder, basically if I click a button, it's going to turn off the redstone. By default, the redstone is going to be turned on because it's lit up by a torch. So basically for how Minecraft works is, if you have a redstone on the ground and you put a torch on the ground, it will light up the redstone. But if you put a button, or let's say a lever in this case, let's say a lever, if I were to turn on the lever with an already lit redstone, it's going to turn the redstone off instead. Okay, that's not working. Let me try with a button. I think I did it wrong real quick. I think I did it wrong. Let's do this instead. Or let's just do this, like this. Okay, that's not working. I think I did something. Oh, okay, I get it. So it's like this instead. So if you put a button on a redstone torch, if you turn on the button, if you click the button on a redstone torch, it's going to turn off the redstone torch. Yep. Yep. Okay. And also one more thing is an off redstone turns on a redstone torch instead. So right now, or like this, an off redstone torch. Like this. Let me just, this won't take too long. So okay, let's just do this. Yeah, an on redstone redstone dust turns off the redstone torch, but once the redstone dust becomes off, it turns on the redstone torch. So that's how the encoder is going to work. Sorry if I took too long to explain that because it's really important for this one. So let's say for this one, this is input 1. It's going to turn off this line of redstone. And once it turns off, it turns on this redstone that connects to this output, which is 1. In this case, this is 1, this is 2, this is 4, this is 8. So if I click 2, yeah, it's gonna turn off this, and it's gonna light up the redstone, and it's gonna go over here. Now it's gonna turn on 2. So what happens if we click 3? Yep, it turns on 2 of these. It turns off this and this, which basically means it's going to light up these 2 torches, and it leads to this 2 output, which is 1 and 2, and it's equals to 3. So now 4, it's going to take a while to light up. Or something is wrong. Oh, the server's lagging, the server's lagging. It could be the server lagging. Oh, I think there's just some malfunction with this, but you get the idea from how I showed you for the 1 and 2. It just repeats the same thing. If I click 5, it's gonna, light off some redstone, and it's gonna connect to 4 and 1. It just repeats. But this thing is just broken because the server is kind of lagging, and it makes the chunk kind of load incorrectly. So now that I've explained the encoder, now we have a decoder. So to sum it up again, we have an encoder. An encoder turns the input into binary output, and a decoder turns the binary output into an actual decimal digit. So let's test it out again. With this one, let's just show case number 1. This is the same calculator, binary calculator, binary addition, an 8-bit binary adder that I showed just now. But this one is connected to an binary, it's connected to an encoder and a decoder. So now let's just put number 1. It should output number 1 because, so this is an encoder. I've already explained how an encoder works. And a decoder takes an output from the encoder. So as you can see here, it takes in here. Okay, so it takes in this specific spot, and this specific spot is gonna light up. It's gonna light up this specific part. And one more, which is, let's spot it real quick. One more is here, and it's gonna light up this specific spot. So that's how 1 is displayed, because it takes in input from the encoder and it lights up specific spots. So for 1, it only lights up here and here. That connects to this 2 line right here, which is 1. So if it's 2, it's connected to different spots. So yeah, it displays 2 because it's connected to, it lights up these specific spots that lights up these specific lines to display the number 2. And this is also an addition calculator. So we can put 3 plus 1 should equals to 4. Oh wait, oh this is 4. Okay, 4 plus 1 is 5. Okay, so now you guys understand how a decoder works. So this is just our process. We've made an encoder, now we've connected the encoder to the binary adder, and then we connected it to a decoder that connects to the display. So now if you guys understood how the numbers are displayed and how binary addition works. So now, after that, after we made the decoder, we've made a more compacted decoder, because obviously you cannot, we're making an 8-bit calculator. We're making an 8-bit calculator, and we're gonna have to display 3 numbers. And if it takes this much space to display 3 numbers, then it's not possible. So we have to make it more compact, like this. This is also a decoder. So I'm gonna show you real quick. It's basically the same thing. It's just more compact. So this is 1. Okay, so now it's on. It's gonna light up this and that. So lighting up this connects to up here, and up here it lights up here, and one more down here as well. It lights up this specific spot, so it can light up here. So that displays 1. It's basically the same exact thing, but I'm gonna show you one more how it can display 2. So now when you turn on 2, it's gonna turn off this redstone dust. But like I said, turning off redstone dust will turn on a redstone torch that is next to it. So yeah, it turned on, these four redstone torch, which which connects to this part to turn on these specific redstone lamps. So yeah, now you understand how this and a decoder works, this more compacted decoder. So now what we did was we copy pasted that decoder into this giant display. So we copy pasted 6 times. So now we have 6 digits, 3 for the upper number and 3 for the bottom number. So yeah, so yeah, this is an encoder which I showed you, but this is just connected to a way longer path because we gotta, we gotta show it. If it's too close, you guys can't really see it properly. So we gotta make it kind of far, so that's why it's kind of far. So yeah, it's basically the same thing. If I click 1, it's gonna show 1. And you guys understand why, because I already showed it earlier, how it displays. But here comes another confusion. Why does it, when I click 1, why does it only show for that one? Why doesn't it show for everything, basically? So here's why. So first, we have this thing called, we use this method called repeater locking, which basically means that if you put a repeater this way and you put a repeater that way, oh, my bad, it's gonna lock this repeater, which basically means even if I remove all the redstone, it's still, oh wait, hold on a minute. This, okay, so it's locked. Now when I remove this, oh wait, I think I did it wrong again. It's locked, and even if I remove the thing that powers that redstone, it still powers on. So this is a method that we use because, as you can see here, so when we turn it on, it's gonna go up here and it's gonna lock it in place, and it prevents this from going to other place. So let me just turn it off. This is a clear button as well, by the way. It basically resets everything. It's gonna temporarily depowers everything, and it gives it enough time to reset it back to normal. And I haven't explained it yet, but how 0 is displayed, it displays when nothing is turned on. So when there's no input, it just automatically just 0. So all right, so now it's, yeah, see, it's locked. It's locked. So there's no power going in there. So now when I click 1, yep, it's gonna power through here. I forgot to mention there's also a signal. So if I click 1, it turns on the signal, a signal output. So the signal output comes with every input. So if you input 1, it's gonna output binary 1 and signal. So the signal basically powers this one, and it basically it powers here to depower this one. So it can, it can temporarily depowers this one. I mean, it temporarily stops the locking so the input can come through. So after it comes through, it's gonna lock it. That's what I mean. So yeah. So I hope my explanation makes sense. So 1, yep. Now it's locked there, but this is locked. You see what I mean? That's what the repeater locking is for. If there's no repeater locking, everything will display 1 and that'll be a problem. So if we display 2, if I display 2, the input of 2 will basically push the input of 1 to the one right here. And the 2 will be here instead, so it'll become 21. So, oh no, 12, 12. I meant 12, I meant 12. So it'll push 1 to the side, and 2 will come in as the new first digit. So yeah. So it pushes this here, and this will become 2. And yep, this one is also locked. And yeah, I think you guys understand why now. I hope it makes sense why the 3 digits, which, and yeah, and we have this lever right here. This lever right here, basically the lever is connected to this part of the component, and it basically, if the lever is pulled down, it locks the top. So it only goes to the down part, which is another 6 display, another 3 display. So it locks the top and it goes only to the bottom, and vice versa. If I make it to the top, it locks the bottom. So that's how I made it to display the top and bottom digit. So I already put it to the bottom digit. Let's try it out. And yep, the bottom shows 1, the top doesn't do anything because it's locked. So now let's just clear it. And now let's move on to the final part, which is this thing. And my teammate actually built this, so I don't have an actual understanding of it, but I do understand how it works. So I'm gonna explain how this works because I was still in charge of the routing. So basically, when I click 1, the 1 signals to the display, but not only it signals to the display, it also signals to here. So it basically splits up. It goes here and also here. So it's gonna go and just like top and bottom, we also have a top and bottom here. This is the top, this is the bottom. So what these are for, they are for storing value. So this one just displays empty numbers, but this thing actually stores actual number values that actually calculates it. So now 1 is at the bottom, so it's going to store 1 at the bottom, which is here. I really hope it's not broken because the chunk rendering is kind of broken and I don't really know, but we did show it in a demonstration, but I think this is broken and I hope it's not broken, but I'll still explain it even if it's broken because I don't. Okay, so 1. So it should store 1 up here. Yep, it's storing 1 right now. This is 1, this is 2, this is 4, this is 8. You guys get the idea? So this is 1. And it stores the number. So now, let's click 2. And it should store 2 in this. It should store 2 here, but it's not working because, like I said, this is a server. So things can go wrong because it's a server. The chunks may not load correctly. We've dealt with that a lot, and I just figured it just now. It's not because of our mistake. It's actually because of the server mistake because it could lag, and some parts of the chunk might go missing. Some blocks might go missing. It could ruin the whole thing, and it takes forever to debug. So I'm not gonna try to debug it right now. It's gonna take a while. So yeah. So the second one should actually stores number 2 in the bottom input or the bottom storage, and it comes together, it collides with each other, and it connects to this thing again, which I already showed you, which is a binary adder. And now it should display the output, which should be 3, but it's 1. I think it works if I do this instead. Let's try with just number 1. I think number 1 works, but number 2 doesn't work. Okay, 1 plus 1. And the answer should be 2. And no, it doesn't work. But usually, it's supposed to light up here, like I said, because the chunks doesn't load correctly. So yeah, it should be like this. It's supposed to be 2. And yeah, anyways, I think that's it for our explanation for how it works in the final demonstration. This is just to prove that we've actually built it and we've actually learned something from the project. It's not like we just copied it. And yeah, thank you for watching, and that's it. Goodbye.